welcome to True Projects. In this video, we are going to explain about the project that is Hybrid Top Features Extraction Model for detecting X rumors events and Ensemble model. So before getting into the execution, first let us understand what is this project about. Social media platforms like Twitter, Facebook, and Weibo have completely changed the way we communicate. Now anyone can instantly share news, opinions, or updates with millions of people around the world. While this is amazing for connecting people, it also has a downside because anyone can post anything. False information or rumors can spread just as quickly as real news. These rumors, these rumors can have serious consequences. People might believe them and make wrong decisions, or they could cause panic, damage someone's reputation, or even create bigger problems for society or national security. The speed at which information travels online is so fast that once rumor starts, it can reach thousands or millions of people before anyone has chance to verify it. That's why it is really important to have reliable ways to detect and stop false information before it causes harm. And finding rumors on social media isn't easy. The data on these platforms is messy. It is full of slang, emojis, links, images, and other type of content. So it is not neatly organized. That makes it hard to tell what is true and what is false. On top of that, the majority of posts are actually genuine information, while rumors are much less common. This imbalance makes it tricky for traditional models to detect the smaller number of rumors. They tend to focus more on majority of normal posts. And here, another challenge is figuring out which pieces of information or the features are actually important for making a correct prediction. With so much data, choosing the right features is crucial. And even if you pick the right ones, getting the model to be highly accurate is still hard. All of these difficulties together make rumor detection a tough problem that needs smart, reliable, and well designed solutions. So, to overcome with all such issues, system we are proposing is called hybrid ensemble learning, that is hybrid ensemble algorithm, that is HEA, and it is designed to detect rumors on social media more effectively. The idea here is to combine a few smart techniques to make the model more accurate. Here, first, we use Pearson correlation analysis. This basically helps us to look at all the features in the data and figure out which ones are too similar or redundant. So, by removing these repeated or highly related features, we only keep the ones that really matter for detecting rumors. This makes the model simpler, faster, and more accurate. And here, one big challenge in detecting rumors is that there are usually a lot of normal posts than the rumors, which can make the model biased. It tends to just predict not a rumor most of the time. To fix this, the system uses smooth technique, that is synthetic minority oversampling technique and also random undersampling technique. Smooth it works by creating synthetic samples of the minority class that it generates fake rumor posts based on the ones we already have. This helps the model to see more examples of rumors. On the other hand, random undersampling it reduces the number of normal posts so they don't overwhelm the dataset. By combining these two methods, the dataset becomes more balanced, giving the model a fair chance to learn what a rumor actually looks like. And after balancing, the system needs to figure out which features, basically pieces of information, are the most important for predicting whether a post is rumor. To do this, this project it uses random forest classifier. This model can rank the features based on how much they help in making accurate predictions. Only the most significant features are kept and passed on to the next step. Next, these selected features are used in ensemble models, which means we combine several different types of classifiers that are decision tree, k nearest neighbor, ADA boost, and convolutional neural net. Each model has its own way of looking at the data. So, by combining them, the system can catch more patterns and make better predictions. Finally, we will be evaluating all of the models using these metrics that are precision, recall, FN score, and accuracy, which tells us how well the model is doing at correctly identifying rumors without making too many mistakes. And to further improve the performance of this project, several enhancements were made to this. So first we have handled the data by using feature redundant technique with smoothing sampling in a stacking model. Stacking is an ensemble model which is also added an extension. So this helps, that is smoothing technique, it helps to balance the data set while keeping the only most important features, which makes the model more efficient and accurate. So by using feature reduction with the smoothing technique, we will be only just keeping the most important features with the balanced data set. And we will be feeding that data into the stacking model, which is an ensemble model, which combines multiple ensemble models. That is multiple models into one ensemble model. Then comes live data integration. So at this step, the system fetches the real-time tweets from Twitter using Twicket library. So users simply enter a username and the number of tweets they want to check, and the model predicts each tweet as either a rumor or non-rumor right away. Finally, we built a user-friendly interface using Flask where users can log in and provide input. We also have included explainable AI technique like Lime and Chap, which shows the features influence the model predictions. This makes the results easier to understand and adds transparency to decision-making process. And to implement this project, here we have followed the steps which are mentioned in the flow of work. So let's understand how we have implemented this project. First comes importing library. So first we have imported all the necessary Python libraries that will help with the data handling, processing, model building, and building the web application. Then comes loader data, that is data ingestion. At this step, we will be loading PHEME dataset which comes in JSON files that we will be loading into Pandas data frame so it can easily be processed and analyzed. Then comes data pre-processing. So here at this stage, we clean the data by handling missing values, converting categorical variables into numericals, that is numbers, using label encoding, and standardizing numeric features. We clean and prepare the text by converting it into lowercase, removing HTML tags, URLs, special characters, and handling punctuations. Then we tokenize the text using either a tokenizer or TF-IDF vectorizer to convert it into format that the model can understand. Then comes recursive feature elimination, which is an extension part. So at this step, we use recursive feature elimination, that is RFE, to pick the most important features, which helps to reduce complexity and improve the model performance, especially for the extension model. Then comes data resampling. So at this stage, to deal with the class imbalance, we apply smooth and random undersampling technique. So here we are applying random undersampling technique. For the extension models, we use smoothing technique, which balances the data even more effectively. Then comes feature extraction. So at this step, after cleaning and balancing the data, we extract the features from JSON files and split the dataset into training and testing sets for building and evaluating the models. Then comes model building and evaluating. So at this stage, we train different machine learning models on the prepared dataset to detect rumors. For feature-based analysis, we try multiple models and use ensemble techniques to improve the performance. Then comes evaluation, where we will be evaluating all the models built using accuracy, precision, recall, and FN's code. And we use confusion matrix to see where the model makes mistakes, like false positives and false negatives. And we have also applied explainable AI technique, that is Lime and Chap, to understand which features are influencing model predictions. And we will be saving the best performing model for the future use. And coming to the part of front end, so users can upload JSON files or provide a username and the tweet count for real-time prediction, and load the saved model, scalar and encoder, pre-process and separate incoming feature-based and text-based data, fetch live tweets using Wicked process, and predict whether each tweet is rumor or non-rumor, and display results on the user result page. Moving on. So these are the algorithms used in this project. So we have used decision tree, random forest, k nearest neighbor, ADA boost, neural network, the proposed model, that is ensemble, which combines decision tree, KNN, ADA boost, CNN, and the stacking classifier, which is an extension model. And to implement this project, basically we need two kinds of requirements, that is hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB, and hard disk of 25 GB and above. Software requirements are application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open it. These are the source code files of the project. Let's understand each of them. In this model folder, we have the algorithm information that is stored in .h5 files, numpy files, and pickle files. They will be loaded into the project code during runtime of the application. And in this folder, we have the data set that is used. So here we have multiple users, that is multiple events. So here we have the user of Charlie Hebdo, and here we have non-rumors. So these are non-rumor JSON files. Here we have files, and here we have rumor files. Let's get back. Similarly, we will be having in all these events also. Let's get back. And here we have static folder in which we have CSS, JavaScript and Bootstrap files which are important for the project's appeal. And here we have templates folder. This folder contains all the HTML pages used in this project. It typically includes files like index.html, about.html, etc. which represent different pages of the website. And in this folder, we have the test cases that we will be using in the front end. And here we have app.py file. So this .py file, it contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have JSON features Python file. Here we have notebook file. So here we have multiple notebook files. These are the Jupyter notebook files which contain a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. And this file is for the rumor real-time prediction. And here we have signup.db file. This file is a database file which is used to store the user information. So this is all about the code folder. Now let's execute. So copy the path of the code folder from the address bar of the file explorer. I have copied it. Now open Anaconda prompt. So it is open. Now give the command cd, give the space, paste the copied path, click on enter. Here, if you observe, current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. This command will execute Python script and perform a runtime check for any syntax errors or logical issues. And after running the app.py file, Flash Framework will host the application locally at the default address, which is the localhost and the port, unless configured differently. So file is being compiled, so just wait for a while. And here application has been hosted at this address. So this is the local host and this 5000 is the port. Now copy this local link provided by the Flash framework and paste it in any web browser. So copy it. I prefer Chrome, so I will paste the link in that. Paste the link here. Now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So we need to get registered first. Click on register and create an account. Enter all these details and then create an account. I have already created account, so I'll directly log in. Click on login and give username and the password. Click on login. We have logged in successfully and redirected to prediction page of this project. So here we will be doing two kinds of prediction, one with the live data and the other one with the JSON data. So first let's do with the JSON data. So click on that. And here you can see choose file button, right? We need to click on that for uploading the JSON files to predict the whether that Twitter is rumor or a not rumor. So click on it and now open test cases. So we have test cases in that. Let's open rumor folder. And here we have multiple JSON files in which we have the Twitter text, that is X text. So let's try uploading this one. Click on open and now click on predict. So this given JSON file, it will be pre-processed at the backend. It will be fed to the train model and then train model will be giving us a prediction. So this is the input text that we have given. That is 17-year-old unmarried kid shot 10 times by police for stealing candy. I didn't know that was punishable by death. So this was the text that we have given, which was in the JSON file. And here we have prediction as rumor. So this given input text is the rumor with the confidence of 0.78, that is 78%, it is confident. And this is the extracted features. So here, this is the in reply tweet, which values is 0, event is 0. Here is the tweet ID, which was posted. So this was a user who has posted this tweet and replies were 0, events were 0. And in reply user were also 0. User ID, this is the user ID. This is the Twitter ID and this is the user ID. And here we have tweet length is of 138 words. There is 138 letters. And here we have URL count, tweet count, favorite count, created, and we have all the other stats also. Now let's try again with the another JSON file. So click on choose file. Let us upload this one. I'm just applying randomly. So click on predict. And here we got the prediction. So this is the predicted. This is the text that we have given. For this given text, it is predicting it as rumor with the 96% confidence. And here we have extracted features for this input text that we have given, which was in the JSON file. And this was a user ID who have created this tweet. And this is the tweet ID. And here we have all other stats. Now let's try with the other one. Click on choose file. Let's try with this one and click on predict. And here we have prediction. This is the uploaded input text. And here we have prediction as rumor with the confidence of 59%. And here we have extracted features. Now let's try with the other class. So click on choose file, open test cases, open non-rumors. Let's try with this one. Click on predict. Here we got the prediction. This is the uploaded text. And here we have prediction as non-rumor. And this is the confidence for that rumor. And this is all the information. Let's get back and try with the other file. Click on choose file. Now let's upload this one. And for this text also that we have given, it is predicting it as non-rumor within 99% confidence. It is very accurate. And this is the user ID. And here we have tweet ID. Now let's check with the real time. So click on predictions. Under prediction, click on live data. Here we are supposed to give the username, and here we have number of tweets. Here in test cases, we have some normal files, that is normal usernames. So let's open real time. Let's open this. Let's copy this one. Here are the human IDs and here are the bot IDs, which are now paste the tweet, that is paste tweet username, and let's give the user, that is number of tweets are 4, and now click on check. Now text will be extracted from Twitter, that is X. So this is the tweet ID, and here we have the text extracted from this tweet, and this is the created, and here we have user ID, and here we have username, that is 1120 rule, and here we have retweet count. So this was retweeted this many times, and favorite count is 0. Number of followers for that account is 232. Here we have user listed count, that is 2. In reply tweet is 0, and then tweet length is 71. URL count is 1. Number punch is 4, and capital ratio, here we have capital ratio. So here we have predicted as not rumor. It is not rumor. And here you can see all the predicted cases for all the given 4 tweets. Now let's try again with the other user. So click on enter name, and here let's try with this case, Bitcoin. Enter it. Let's give number of tweets as 5. Click on check. And here we have no rows to display because there is no account. Now let's try with this one. Get back. Click on try again. Paste the username, and let's give number of tweets as 4. Let's give it as 3. And here we got the data fetched from the Twitter. So here is the tweet ID. Here we have text. Here we have created, and here we have user ID. Here we have username for the all the text that we have for all the tweet IDs. And here we have prediction as non-tumor. That is non-rumor, sorry. Now let's try with the other one. So let's open the board file. Let's check with this one. Paste it. Number of tweets are 10. Click on check. And here we have no data available. Let's check with the other one. So let's try with this one. Click on try again. Paste it. Give it 3. So here we got the detection from the given user ID. Here we have tweet IDs. Here we have text, and here we have created user ID, username, and retweet count, favorite count, so on. And here we have the prediction, that is no rumor. So as of now, all the usernames which we have given were of no rumors, that is not rumors. Now let's check with the graphs. Click on graph. And here, this is the sample outcome graph where blue color is non-rumors and the orange color one is rumors. Here you can observe non-rumor cases are more than the rumors. So that is why we have used data sampling techniques, that is Smotin, undersampling technique, and the SMOT technique. And here we have Pearson correlation matrix, which shows the correlation between independent features. So, features which are more correlated, they will be dropped out. And here we have confusion matrix. This is the confusion matrix. And here is the accuracy comparison graph. Here on x-axis, we have all the models that we have trained, and on y-axis, we have accuracy score. This is the precision comparison graph. This is the recall comparison graph. And this is the FN score comparison graph. Now click on logout. So, with the rise of social media, rumors can spread quickly and cause real world problems. Our system helps to identify these rumors accurately and in real time, also giving people and organizations the information they need to act wisely. By combining smart data analysis and live predictions, it makes social media safer and more reliable for everyone. This is all about the project.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.